All right, so welcome to the July meeting of the Johnson Space Center Astronomical Society. I'm Doug Holland, president of JSCAS, and this is tonight's agenda. If you have questions or comments during the meeting, please either put your questions or comments into the YouTube comments area, if you have an account that will let you do that, or you can email your questions to jscaslive@gmail.com. And our producer for tonight is Trevor Quinn, and he will take those questions and he will read those to our presenters. And also a special thanks for Trevor for figuring out the YouTube channel and getting all this working for our club. So on our agenda, we're going to have Meteors and Meteorites with Bill Spizzirri. And Chris Wells will be bringing us a DIY astronomy automated imaging results. Then I will have a members minute about how do you say that. And we'll wrap it all up with Star Party News with David Haviland. So, before Bill starts, I'd like to tell you a little bit about him. Bill is a retired mainframe software engineer from Chicago. He has been studying astronomy for about 65 years. He has belonged to several astronomy clubs for 42 years and served in various offices, including president of an astronomy club in Chicago. His favorite astronomy activity is teaching children and the general public. He currently lives in Katy to be near his 3 grandchildren. So with that, I'd like to turn it over to Bill Spizzirri, Meteors and Meteorites.
Okay, can you hear me? Hello, can you hear me?
You're good.
Okay, and can you see my slide?
You're good to go.
Okay, all right. Normally I would start by saying it's good to see you all. We'll skip that part, but I'm glad all of you can make it. All right, meteors and meteorites. Just to make sure we're on the same page, when we say meteors, you're out at night, a clear sky, dark place, lots of stars, no clouds, and you see a streak of light in the sky. People call that a shooting star. Of course, it isn't. No, I'm not going to say of course, but it isn't a star of any kind. It's a rock flying through outer space, gets attracted by Earth's gravity, enters our atmosphere at about 50,000 miles an hour. Pressure starts to build up in the air in front of it. That heats the air. The hot air heats the meteor. When it hits about 2,000 degrees or so, the rock burns up. And as the rock is burning up, that's the streak of light you see in the sky. So not a shooting star, it's a burning rock. Here is a picture of one. Now this is a really nice one. You might not always see a nice meteor like this, but that's what it looks like when a rock is burning up in our atmosphere. Here's another one, even better one. You got the Milky Way in the background and you got the reflection on the lake. So you might not always see nice ones like this. Don't complain to me. These are rare. Okay. So when the rock is still in outer space, we call it an asteroid. Here's a picture of an asteroid. This is a really big asteroid called VESTA, over 300 miles across. It's the big rock with a lot of craters shaped like a potato. All right. And we have the pictures of VESTA because we sent this spacecraft, the Dawn spacecraft, several years ago, NASA spacecraft. And here it is, a representation of it approaching VESTA. And the big blue light coming out that's back end there is because it doesn't use a conventional chemical rocket. It uses ion propulsion, which is a little too complicated to get into now, but that's just what the Dawn spacecraft looks like. You look at VESTA and you can see the craters and you can see these ridges. By the way, can you guys see my cursor okay? I hope. All right, so these ridges were caused by Dawn getting an impact with another asteroid down over here, and it squashed Dawn. And so these are the wrinkles. Maybe Dawn was a little rounder at the time, and these are the wrinkles when it had that impact. Here's a quick video of Dawn. Again, Dawn went into orbit around VESTA and created this video. And of course, you can see the ridges. All right, these are the wrinkles that happened when it got impacted down over here. And when it got impacted, it created this mountain. And it doesn't look like much, but if you think about the fact that Dawn is about 300 miles across, this is a big mountain. It's 14 miles high. which makes it the second biggest mountain in the solar system next to the Olympus Mons volcano on Mars. So it doesn't look like much, but it's a significant mountain. So it was a significant impact when that happened. Here's a quick video that shows what it would look like if you were riding in a spacecraft on the Dawn spacecraft orbiting, whoops. Let me try that again. Orbiting VESTA. So these are the stars in the background. Here's VESTA. That's the sun in the background. And on VESTA, you can see the ridges, the wrinkles when it got hit in that impact. So they're really significant mountains. They don't look like much when you see the whole asteroid, but they're big ridges. Okay, here's another asteroid in the asteroid belt. It's nice and round, called Ceres, and because it's round, we call it a dwarf planet. Almost 600 miles across. This is the biggest asteroid in the asteroid belt, and kind of looks like the moon, except for these white spots you see in the crater here. When we first saw them, we didn't understand what they were, but the instruments on the Dawn spacecraft was able to tell us that that is salt. And the reason there's salt on the surface of Ceres is that when the other rock that hit Ceres and made this crater, it punched a hole in the crust of Ceres, and what came up was salt water. And of course, you can't have liquid water when there's no atmosphere. So the water immediately evaporates and leaves the salt on the surface. And what that told us was that there is an underground an underground ocean. We think it's across the entire, under the entire surface of Ceres, of salt water. So similar to Earth in that respect. That was sort of a surprising finding. Here's a close-up of that same crater. Of course, it's got a mountain in the middle too, and you can see the salt sitting on the surface of Ceres. Here's a quick video that was made by the Dawn spacecraft, putting a bunch of pictures together, and you'll see there's many other craters that have the salt coming up. We see it coming up through the crust all over Ceres. So again, a very interesting asteroid. We always thought asteroids would dry. Maybe it's certainly true on the surface, but not underneath. So here's photographs that show Ceres and VESTA together just to compare their sizes and shapes. The colors are just an artifact of the special camera that can identify the different minerals on the surface of the asteroids, and you can certainly see the salt coming through on some of the craters on Ceres. Okay, so these guys are way out in the asteroid belt. And there's lots of other asteroids out there. Who knows? Maybe there's millions of them, certainly thousands of asteroids out in the asteroid belt, all much smaller. Look, you can see these here, 34 kilometers, 54 kilometers. Big rocks, but not as big as those other two. And they have strange names. Somebody trying to...
Bill,
yes?
We have a question for you.
Yes, go ahead.
This is back concerning VESTA. What is the gravitational force of VESTA compared to the Earth?
Well, that is a darn good idea. I think that if you were on VESTA, it's 300 miles across. It's half of the state of Texas. That if you jumped hard, you'd leave VESTA. Okay. Now, I can't say that for sure, but I bet you a shiny dime that's the fact. And but I don't know the exact number of the gravitational field. For instance, you know, the moon's 2,000 miles across, and it's 1/6 of Earth. So you're only going to weigh a couple of pounds. If you're a decent jumper, you could maybe go into orbit if that's what you want to do. Sorry, I think that's the best answer I can give you. Okay, I will move on. Where were we? Okay, this picture here. Oh yeah, and then we saw the other smaller asteroids in the asteroid belt. And, you know, you can name it. If you discover it, you get to name it whatever you want. People have made discoveries and give them interesting names like Mr. Spock and James Bond and all these others that you see here. Or sometimes they just put those long numbers on them to show when they were discovered. But there's lots of asteroids out there in the asteroid belt. Okay, so where's the asteroid belt? Here's a picture of the part of the solar system. You see the sun and the inner planets, all right? The blue lines are the orbits of the planets. So here's the orbit of Mars. Here's the orbit of Jupiter. between the orbits of Mars and Jupiter, you got 1 million rocks flying around the sun in their own orbit, and that's the main asteroid belt. The reason that it's all a bunch of individual rocks and they never become a planet is because they just get a little too close to Jupiter, which is very large, has a very strong gravitational field. And every time they come by, the gravity of Jupiter tugs them back or forward and breaks them up generally. And so they can never coalesce into a single body like a planet. And so probably for the foreseeable future, they will stay a bunch of rocks in that orbit around the sun. So there are many, obviously the main asteroid belt is many millions of miles away from the Earth. And you might ask, well, how does an asteroid get all the way from the asteroid belt to Earth to cause a meteor in our sky? Well, I'll show you one of the ways that happens. Here's a quick video. Here's an asteroid out in the main asteroid belt, flying along, minding his own business, not bothering anybody, and whoops, somebody else gets in the way, and kablooey. And what do you get from that? Well, you can see you get 1 million rocks flying in all directions at a high rate of speed, certainly fast enough to leave the gravitational field of the asteroid. Some will go towards the Earth. They'll get caught in our gravitational field, hit our atmosphere, and we get a nice meteor. So that's one of these collisions happen frequently, or at least relatively frequently, and that's one of the ways we can get meteors in our sky. What I have over here is a photograph of that actually happening. This photograph looks like a comet, but it is not. It is an asteroid. As you can see, a little over a year ago, it was involved in a collision out in the main asteroid belt. The asteroid's 2 miles across, and it's leaving in its orbit a dust trail. And, you know, when you get hit by something a couple thousand miles an hour, that's what happens. So those kind of collisions definitely happen. And the other place we get meteors in our sky from is comets. A comet is like an asteroid, a big rock flying through outer space. The main difference for our purposes is that it also has ice on it, including ice on its surface. When it's far out in space, let's say past the orbit of Jupiter, the ice stays nice and frozen and nothing happens. As it comes close into the sun, it warms up. The ice melts, but of course, again, you can't have liquid water, so the ice just turns to water vapor, steam, and it leaves the head of the comet, partially just because of the solar wind pushing it away. And when that steam leaves the nucleus of the comet, the rock of the comet, it takes with it dust and pebbles and rocks. And so all that stuff ends up in the tail of the comet, and then all that stuff ends up in the orbit of the comet. In this picture here, you can see a diagram where you can see the comet's orbit around the sun. It may be, you know, an orbit of just a few years, or maybe an orbit of hundreds of years. But in any case, it's been going in through that orbit for perhaps millions of years. And so its orbit is filled with all that dust and pebbles and rocks. And then along comes the Earth, and sometimes the Earth will go right through the orbit of the comet. And when that happens, we get hit with a whole bunch of dust and rocks and pebbles, all at one time, more or less. And so we have a lot of meteors in our sky, and that's a meteor shower. Now, of course, the Earth goes around the sun once a year, and so it will go through that comet orbit on the same day every year. So we will get a meteor shower on the same day every year. Sometimes they last several days, sometimes actually a couple of weeks. The orbits can be kind of wide. And so we get lots of, we get a meteor shower. Now, here's an actual, some photographs of Comet P67, and you can actually see the steam and the dust flying off of the comet when it was close to the sun. So that's what it looks like close up. It really happens. It's this is what makes a comet tail. Here's another photograph of a comet. Comet ENCKE 2005, taken from a NASA spacecraft. And you can see the comet here, and the dust is just shooting off of the comet because it's being warmed by the sun. And here's its orbit, and its orbit is just filled with this stuff. This is a Spitzer. This is an infrared image. Dust gets warmed by the sun, so it glows in infrared radiation, and so we can see the dust in the comet orbit. So that really happens. We can see it happening. Here's a quick video with a very odd title, but you might understand why it's called this. It's a video that shows the Earth going through the orbit of a comet. Okay. So it's those are the planets going around, obviously very much speeded up. And so here's the orbit of Earth. Here's Earth, and this is the elongated elliptical orbit of comet Linear. And Earth is about to go through that orbit, and they'll show you a close-up of that. So there's all that junk. Earth goes right through it. We get a beautiful meteor shower. Notice we don't hit the comet. Comet's many miles away, but here's Earth, and look at that. We get a beautiful meteor shower, and that's how they happen. Okay, and of course, the Earth is going around the sun at 67,000 miles an hour. So all those meteors that we are hitting, it looks like they're hitting us, right? They're just a different perspective. And since and so the direction in which we are traveling, denoted by this circle here, that's where the meteors seem to be coming from. That's just called a radiant. That just shows the direction in which the Earth is traveling. And so that radiant is in one constellation or another. Okay. Well, I'll show you that in a minute. Here's just a photograph of a real meteor shower. You want to go out and see meteors, you don't need a telescope or binoculars of any kind. Get out in the dark sky on the right night. All right, you can see all those dates on the internet. And if you're lucky, you get to see a nice meteor shower get in the dark sky. Here's another photograph of a meteor shower. And you can obviously, with the red star is the radiant of this meteor shower. That's the direction in which the Earth is traveling as it's going through this comet orbit. Get a nice bright one over here. And so every comet shower, every meteor shower has a radiant like this. And if you're out there and you see a lot of them, you'll be able to recognize where the radiant is. So this spot over here is going to be one constellation or another, Big Dipper or Orion or Gemini or something. And so they will name that meteor shower after that constellation. In this case, the radiant here is the constellation Gemini. And so they call this the Geminid meteor shower. All right. Oh, by the way, here's a picture of a meteor. In case you happen to be in orbit anytime soon, you'll see the Earth, and here's the atmosphere, thin atmosphere. And you can see this is how the meteors look from outer space, which kind of shows you they are, in fact, happening in the atmosphere, not out in outer space, as it were. Here's another image from a NASA satellite. 1997, 48 image long exposure, 48 minutes exposure of the Leonids meteor shower, which occurs in November. And as you can see, Leonids can sometimes be a very active meteor shower. There's a lot of meteors when you go through a comet orbit. Here are major meteor showers. There's hundreds of minor meteor showers throughout the year. And again, the same day for each one on the year. But here's the, let's see, what do we got coming up here? The end of July, this is the maximum where you see the most meteors in this particular shower, the Delta Aquariids. So the radiant is in the constellation Aquarius. All right. So these are the ones for this year. Sorry, there's a first quarter moon. Might be good, might not. But you can see all these dates on the internet. So we've been talking about meteors. I'm going to show you a video. This video is troublesome. All the stars you see here are, all the dots you see here are stars. Watch in the lower left-hand corner. If the thing works, you'll see a meteor. Here it goes. Didn't last very long. Okay. Very short, 2 seconds or so. Why? It was a tiny little, maybe a grain of sand at 2,000 degrees. Here's another one. See if you can see the meteor on this one. It might be visible. There you go. It explodes a few times, burns up, and it's gone. It lasted longer. Why? The bigger rock. The bigger the rock, the more spectacular the meteor. We'll skip that one. Here is one the size of a basketball. This guy happened to have his video camera out at the right place at the right time. This is about 1993, I believe. All right, he's in the right place. Now that's a street light that just got in the way for a second. So he's following it, and as you can see, it's leaving a smoke trail. It's burning up at about 2,000 degrees. You can see it's breaking into pieces, each one becoming a separate meteor. and it's coming in at a very low angle, so he's getting a nice long view of it here. It lasted a long time. It was seen across several states, and then a big piece of it ended up in the back of this lady's Chevrolet. Here's the car. You can kind of see the dent, can't you? I believe it's visible. On the left-hand side, you can see the rock that made that slight indentation on the car. And you can also see the owner of the car looking a little glum on the stairway there because she had to explain it to her insurance man. Yeah, Joe, it was a rock from outer space. Honest, I didn't hit anybody. But she got happier later because it doesn't happen often. So the car got famous. She sold it for a lot of money. It toured the world. And so she was happier later. But the day it happened, I guess when you come out of your house and you see that, you're bummed out. A friend of mine has this rock because he's a meteorite collector, and the poor guy just can't help himself. And he buys them all the time. Anyway, so that was a big one. Now, they don't hit cars very often, to be sure, but I know of one other case when that happened, and that was here in Illinois, 1938, a significantly older vehicle there. And there's the happy owner with the rock. And here's a diagram of what happened. You know, they hit the atmosphere at 50,000 miles an hour, but they slow down significantly as they go through the atmosphere. But it was going fast enough to go through the roof of his garage. You know, he put the car in the garage to keep it safe, right? He went through the roof of his garage, went through the roof of the car, went through the seat cushion, went through the floor of the car, hit the muffler, and then ended up on the floor in the garage. So this was going more than 10 miles an hour. This has gone probably a couple hundred miles an hour when it hit his property. Here again is the happy owner, the lady, with the rock and the seat cushion, and people looking in disbelief. I knew about this particular event not because I was around in 1938, but they have this display at the Natural History Museum in Chicago, the Field Museum, if you're familiar with it. And there's the roof, and there's the rock, and the diagram, and the seat cushion, and the dented muffler. So all the evidence you possibly could want. I doubt if it was fake news. I'm pretty sure this really happened.
Hey, Bill?
Yes, sir.
Back on the one that struck the Chevy.
Yes.
Was the makeup of the rock, was it a palisite?
No, it was not. It's no, it's a more ordinary stony meteorite. I hope that answers your question. Oh, by the way, my friend who has a collection of meteor, he has more collections than you have pens and pencils in your house. He has more meteorites. He has every room of his house is filled with shelves with meteorites, and he has a book, a 1-inch thick book with his entire collection in it. If anybody's interested in seeing all that, get a hold of me, and I can tell you how to get the book. So that's what I know about that. I hope that answers your question. Okay, so here's one that I saw myself in Katy. Oh my God, it's 6 years ago now, 5.5 years ago. I'm out in my backyard. There was a meteor shower that night. My daughter says, "Dad, there's a meteor shower. Go out." I said, "I'm in my lazy boy chair." Well, okay. I go outside in the backyard. I'm out 5 minutes out in my backyard right here in light polluted Katy. And this is exactly what I saw. A green ball, very bright, with an orange tail coming straight down. I did not take this picture, but it was seen all over Texas. Lots of people photographed it. It scared the bejeebas out of me because it looked like it was just a couple miles away. I think it was around San Antonio. That's how bright this doggone thing was. And so this is what you call a fireball. When they're brighter than Venus, they call it a fireball, and this was way brighter than Venus. Now, please don't complain to me if you don't see them like this. This is extremely rare, but it was one heck of a nice one. The colors were very vivid. So this is what's going to be on the test, everybody. When the rock is in space, it's an asteroid. The streak of light you see in the sky is the meteorite. And if you find the rock on the ground, excuse me, did I say this is going to be on the test? The streak of light you see in the sky is the meteor before you start complaining. And if you find the rock on the ground, that's a meteorite. And of course, if you find a rock on the ground and it's not from space, it's a meteor wrong. There are very few meteor jokes. That's might be the only one I know.
Hey, Bill.
Okay. Yes, sir.
We have another one that says many are speculating about mining asteroids. Which has the most valuable minerals?
Oh, well, well, well. You know, how much is something worth? The answer is it depends on what someone is willing to pay for it, right? So there's certainly asteroids out there that are almost solid iron, and that is a prime target. There is a spacecraft mission planned for an asteroid called Psyche. I believe I'm pronouncing that correctly, which they believe is the iron and metal-rich core of an object. So you don't have to bother drilling through useless crust. It's just the pure heavy metal core. And that is one that people were thinking about going to. Now, these missions are not for mining. They're just primarily for initial exploration. But if I was an asteroid miner, that's the kind I'd be looking for. All right. I hope that answers your question. Maybe if we're around long enough, we might see that happen. Okay, so the test. Asteroid, meteor, meteorite. Okay, here's a diagram, shows you where meteors happen. All right. We live down here, big mountains, jet planes fly over here, several miles up. Most of the meteors burn up way 30, 40 miles up. Of course, when they hit your car, that means they made it all the way down to the ground. But that's where they usually, you go out and see a meteor shower, that's where most of them are burning up. Here's a iron meteorite. We just talked about iron in an asteroid, right? Here's an iron meteorite. If you find a meteorite that has is pure iron like this, that means it came from the core of an object. All asteroids are formed with iron in their core because all the planets are formed with iron in their core. So if you got an iron meteorite like this one, that's where it came from, the core of a asteroid. Now, as you can see, it's black. It's black because it was burning up at 2,000 degrees on the way down. And the brown is because it sat on the ground in our wet atmosphere for, who knows, tens of thousands of years or more, and it got rusty. And that's typically what iron meteorites look for. By the way, at the end of this presentation, and I'm going to try to move as fast as I can, I have a collection of meteorites. Normally, I would have them on a table and that you can come up and take a look at them. And Lord knows I don't want anybody to touch anything nowadays. But I took pictures of them, and I'll show you my meteorite collection very quickly at the end, including some iron meteorites. Now, if you take an iron meteorite like this, you slice it, and then you polish it just right, they look like this. They have these lines in there. Those lines are there because they are the iron is in a crystal form. It's in a crystal form because when the asteroid solidified out of a molten rock 4.5 billion years ago at the origin of the solar system, it started out as molten rock. It cooled very slowly. While it was molten, the heavier iron sunk to the center. The asteroid cooled very slowly, and when you cool iron slowly, it forms crystals. The asteroid was too small to have volcanoes, so it never melted again. It falls on the Earth. We find it, we cut it open, we slice it open, and you can see the iron crystals. Now, the old iron on Earth that has been on Earth for a long time, that has been inside the Earth, has been melted over and over by volcanoes and plate tectonics, and all the crystals are gone. So when you cut open a piece of iron and you see these lines, you know you got a space rock. Okay, I have some of those. I'll show them to you later. Here's a stony meteorite where the iron comes from the core of the meteor of the asteroid. The stony meteorites or the rocky meteorites come from the crust of the meteorite. As you can see, this guy has a black exterior. He was burning up as he came down. Okay. And here is a better view of that black exterior. It's called the fusion crust because the surface of the rock is actually melted and, you know, fused, if you will, as it's coming down. So the black exterior has the fusion crust from the heat. The interior is not affected by that, as you can see in the half of the rock on the left. So that's another way you see this kind of rock on the ground, pick it up and maybe you'll get rich, or maybe not. Now, whereas the iron comes from the center of the asteroid and the stony meteorites come from the surface crust of the asteroid, somewhere in between, the iron mixes with the ordinary minerals and you get a palisite. In this case, you can see the silver iron, and you can see these green olivine crystals, which is a very, very common mineral out in the solar system and in asteroids. I got some of these. I'll show these to you at the end. Not nice ones like this, but I can show you some. So that's a pallasite. These are more rare. They, of course, are very interesting looking. You slice them, and the light shines through the olivine crystals. They make jewelry out of them. And here is a guy showing a big one. I think he had to cash in a few bonds to buy this one. Now, that's, of course, a very thin slice. He's letting the sun shine through it from behind him. And you can see the light coming through the olivine crystals. And where the light's not coming through, that's iron. So he's got one heck of a big pallasite there. It's a nice one. All right. Now, here's one of the meteorites I can show you later, but I wanted to show it to you now because it's a particular type. It's called a chondrite. And it is the most ancient of the building blocks of the solar system. It's certainly in the area of 4.6 million years old. I'll have to fix that later. This thing is only about 1 inch across. You'll see it better later, which means these little modules, chondrules as they're called, are the little pebbles that became the rocks, that became the boulders, that became the asteroids, that became the planetesimals, that became the planets. These little chondrules are the beginning of planetary formation. And you don't see these too often. A nice lady at a meteorite, the museum in Fort Worth, yeah, loaned it to me. I currently have it. So that's kind of rare. And if you buy them, they cost you a lot of money. She allowed me to loan it from her. If you want to go out and find meteorites, you can go look in your backyard. However, if you want to get the best bet on finding them, you go to Antarctica. Why Antarctica? Because the flat white sheet of ice and the meteorites are black. And you don't have to be a rocket scientist, as they say, to spot them. Now, as you look at these guys, if you're going to Antarctica, you're going to have to get a pair of gloves. I don't know if you people in Houston own gloves. You're going to have to get a pair. And it's tricky. A friend of mine had been there several times and came back in an ambulance once. It's not easy to go to Antarctica, but that's a good place to find them because they're easy to see. Here, this lady found one and is very happy with it, even though it's cold. You can see black rock on ice. By the way, Antarctica is a desert. It almost never snows there. So the black rock sits on the ice and never gets covered up. So hard to get there, but once you get there, they're easy to find. Since the 70s, we found the tens of thousands of them. Let's see, the last figures I got were 2018, 2019. They found 865 more a year ago. So it's tricky to get there, but a good chance you'll come home with something. Here's what they see. They go around a bend and they see the ground covered with them. This is an old photograph when they first start going down there. I'm going to bet you a shiny dime most of those aren't there anymore. And NASA brought them home, or whoever. But there's a lot of meteorites in Antarctica, or at least there have been. Of course, meteorites are always falling, so even though you pick a lot of them up, there more will be appearing at Antarctica near you. And when they find them, they're very happy. I think these guys are very happy, or they're very cold. I can't tell which. Anyway, here's some of the biggest meteorites we've ever found on Earth. You compare it to the size of these people, 31 tons, 20 tons, 25 tons. I love this one with the kids sitting inside. I would love to get a selfie like that. So they're not all small that you find on the ground. There's been some big ones. This is one in Argentina. Actually, these are two pieces of the same. The original one was over 100 tons. This one on the right was extracted from the ground just a few years ago. And by the way, I wanted to mention to you, I've talked to people who have experience with this. If you see a big one like this coming down, here's what you should do. Remember this, step aside, okay? Step aside because, it'll be trouble. Okay.
Hey, Bill,
here. Yes, sir. Go ahead.
You got a couple of questions that came in.
Yes.
One is VESTA the only asteroid with liquid, and is it possible to use any liquids on the asteroid for Earth resources?
Well, first of all, VESTA is not the one that had the underground ocean that was Ceres, okay? But is it the only one? I believe there was a discovery of an asteroid where they were, they can use a spectrometer on it, and they were detecting water. Now, if they're detecting water, that means it's on the surface, which means actually it's ice. And so right away, people say, well, is it an asteroid or is it a comet? Well, a comet has ice and an asteroid doesn't. Well, those lines are being blurred nowadays. Now, we don't have really good detailed information on that many asteroids. As far as I know, the one I just mentioned plus Ceres are the only ones I know of where any water has been detected or ice. So maybe there's lots. Frankly, look at Europa and the other moon, I forget the other moon of Jupiter, and that they're finding underground water on. I wouldn't be surprised at all if there were more asteroids with water, but that has not been confirmed as of yet.
Okay, and another question. Scientists have found meteorites that are claimed to have been torn from Mars.
Oh, you are correct. And thank you, Ed McMahon. We'll be getting to that in just a little while.
Okay.
You are correct, sir. Any other questions?
One more here.
Yes.
Let's see. Where did it go? Being that the southern pole is Antarctica, are there any difference in meteorites landing in pole versus other areas?
Oh, meteorites land everywhere. 70% of the Earth is oceans. So go to the bottom of the ocean. I'll bet you're going to find a lot, but you're going to need more than a pair of gloves, right? So forget the ocean. They're falling all over the place. All right. I once looked in my naivety, I went up to Wisconsin to find meteorites because the farmers there plow their fields, take all the rocks and put them in piles. I thought, wow, how convenient. They do all the work for me. And then after finding nothing, my meteorite experts tell me, Bill, there's nothing in Wisconsin. The glaciers have cleared everything of any value away. So, but they fall everywhere. But that doesn't mean you're going to be able to find them. Oh, wait, look on the YouTube. You'll see the meteorite guys or the meteorite men. And just look up meteorite on YouTube and you'll find guys with their metal detectors out there looking for them. And they look all over in every country, deserts, Antarctica, farmland, farms in Kansas, you name it. So they fall everywhere. That doesn't mean they're easy to find, though. Antarctica has the benefit of a white ground with black rocks. That's why they go there. You'll get better payback that way. Does that answer the question? I hope. Okay, I'm going to assume. Let me know if you need more clarification on that. Here is the big winner, ding, 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 for the biggest meteorite we've ever found on Earth, 60-ton piece of iron in West Africa. If anybody is going to Namibia this weekend, check it out. 80,000 years ago it fell. You can see compared to the size of the person in the back. They didn't even bother to put it in a museum because I don't care how big your pickup is, nobody's going to take this thing, right? They just built this little stadium around it. So that's a big meteorite. All right, now this is the part of the conversation where if I'm live, I put on my hard hat because on a rare occasion, meteorites hit homes. Here's the case, 1982 in Connecticut. It went through the roof. It went through the ceiling. It went through the roof, what came through the ceiling, hit the floor, bounced up into the ceiling again, and then there was the rock, weighed a couple of pounds. Now, for it to bounce off the floor and hit the ceiling again and go through the roof of the ceiling, of course, it was moving a couple 100 miles an hour. And so that happens. Don't worry about it. Sleep tight. You'll probably be okay. Now, here's the only, I used to say, the only case of a person ever being hit by a meteorite. This lady in Alabama, 1954, was taking a nap on her couch, which is a nice, safe place, wouldn't you say? Taking a nap, and this 8.5-pound rock came through the roof of her house, bounced off her console radio, if you remember what those are, if you're over 21, and hit her while she was napping. Now, you might be able to detect she got a little bit of a bruise. She recovered. She was okay. However, I'm going to bet you any money that it woke her up from her nap. Now, I've often in the past would say this is the only documented case of someone being hit by one. However, it recently came to my attention that some new evidence was discovered of another event, which I'm afraid I'm going to have to tell you later. Okay, because now here's a picture where you asked, where do the meteors fall? Meteorites fall not only all over the Earth, but they fall on all the planets. Here's a meteorite on Mars. Here's another meteorite on Mars. Here's another nice iron one on Mars. Okay. Why do we have these pictures? Well, you got the Curiosity and other rovers on Mars. They take a picture and they send them back. So here's our buddy, the moon. The moon has experienced what is called saturation cratering. That means every inch of the moon's a crater. And 99.99% of them are impacts. All right. So a lot of impacts on the moon. And they're still happening on the moon. Here, 2013. Look over here, no crater. Over here, an 18-meter crater, right? These things are happening all the time. Here's a little video that shows you a close-up of an impact. Boom, there's an impact on the moon, all right? So they're going to show you what happened. And the camera is going to just zoom in and shows you what happens when you get one of these rocks hitting you at a nice high rate of speed. And there's before and after. Before and after. There's the crater, and you can see all the ejecta. Look at all that material that was thrown out of that crater. All right. So this happens very often. Here's a video that shows we got telescopes looking at the moon all the time, and we see these impacts happening all the time on the moon. So here's another place where you can maybe go find meteorites if it's convenient for you. Get in your spaceship. All right. So lots of impacts happening all the time. Here's a new impact on the moon, on Mars. We've been recording a couple hundred of them a year. All right. And as was mentioned later, we went to the moon to get moon rocks, and we hope to go to Mars to get Mars rocks. However, sometimes they come to us. All right. Here's a couple of meteorites on the top over here that are moon rocks. And we know they're moon rocks because we brought back rocks from the Apollo missions. We know the moon rocks are different. And when we see these, we can compare them to the rocks that we have, and we know that these meteorites came from the moon. The ones on the bottom are Mars rocks. We know they're Mars rocks because we've got landers and rovers on Mars. They have sampled the atmosphere. We know exactly what the atmosphere of Mars is like. We open up these meteorites. We find little bubbles inside the rock with tiny microscopic pieces of atmosphere in them. We analyze that atmosphere, and we can definitely identify it as Martian atmosphere. So, as was asked earlier, we do get meteorites from Mars. Says here, it depends who you ask how many there are. But, there's several hundred from the moon and the Mars, that to be sure. And so just sit back and in your backyard, maybe you'll get lucky. Maybe not. I hope it doesn't hit you. Here's a Martian meteorite that fell in Africa. It was discovered in 1997, a little bit of volcanic lava from Mars. And I will show you a tiny, tiny, tiny piece of this at the end of the presentation, if I still have time. Okay, here's some of the biggest craters on Earth. These little meteorites that we see don't make craters, but these are big ones. Look at these things, 80 miles across, 56 miles across, 190 miles across, right? They're not easy to see, but they're out there. This is an odd-looking one because it's underwater. And it's underwater because it's the one off the coast of Yucatan Peninsula, which was the dinosaur killer 65 million years ago. So that's 110 miles across. I believe the object was 7 miles across, a big rock. And so it made a big crater. Here's a beautiful one. If you're going to Mauritania anytime soon, over a mile across out in the desert in Mauritania. It was created 21,000 years ago. Absolutely gorgeous crater. All right. If you're not going to Mauritania, here's one you could see a little easier. Northern Arizona, cleverly named Meteor Crater. It's about a mile across. What is it, about 800 feet deep, I think. These tiny little dots are trees, full-grown trees, so you can get a feeling. Here you can see the road here, how big that crater is. You can go right up to the edge of the crater nowadays. I think they try to discourage you from going down there because most likely you won't be able to climb up, but you can go to the edge of the crater. There's a road trip for you. This is a diagram that shows when that meteor crater occurred, within this 10 kilometers, everything was killed. There was a fireball. It was like an H-bomb, no exaggeration. Here, animals were killed 16 kilometers away. all right, and hurricane force wind up to 30 kilometers away. So a huge impact with a huge explosion. When it comes down at 50, 60,000 miles an hour, a lot of the rock of the asteroid and a lot of the rock of the Earth is instantly vaporized. Tremendous heat, and so it's a big explosion. It's like an H-bomb. So that's real bad for the property value when that happens. Here is a crater, a town in Germany in a crater. Now, this ring you see here is not the crater. This is the wall that was built around the town in the medieval era a couple of centuries ago. But in this diagram over here, you can see the city wall, right? And then you can see the crater that they live in. And they, of course, didn't know they actually lived in a crater until Gene Shoemaker, the late Gene Shoemaker, a real meteor, asteroid, comet expert, visited the town, looked at their church. He was there with his wife, saw the rock that the church was made out of, could tell it was rock that was created by an impact, did some research, and discovered that they were inside a crater. And this diagram shows what it was. Okay. Oh, you might have heard Tunguska event, 1908. The anniversary was just a few days ago, June 30th, which is why they made that day International Asteroid Day. I'm glad that if you attended that party, you came back in time. There's some things we know about this event. There's some things a lot of things we don't know. The map shows you where it happened. This is called the middle of nowhere, out in central Russia, Siberia, the Tunguska, because that's the name of the river that's nearby. So the explosion flattened 800 square miles of forest, millions of trees. Something happened. That is certainty. There is no crater. It broke several windows in town. All right. The largest witnessed. Oh, it is the largest. Yeah, the largest impact witnessed by humans. Many other large impacts. I showed you the craters before, but this is where there was some witnesses. Now, there's no crater, so it was an air burst. This is what we think. I'll show you one of those actually happening later. They think somewhere between 3 and 6 miles up. It's an estimate. Was it an asteroid? Was it a comet? We don't know. How big was it? We don't know. The speed, there's different estimates depending on many estimates, many factors. We're not sure what the angle was. So the size and the angle, the speed, that can change all these factors. And the reports are that there were 3 fatalities from it. Don't know the details of that at all. And it killed some reindeers, which made me cry. So that's Tunguska, 1908. No crater, but one heck of an event. Now, I mentioned to you that we saw the lady hit by the meteorite, and I said that in the past I would say that was the only one, a documented case of a person hit by a meteorite. However, it recently came to light that in 1888, there was an event over here in northeast Iraq where a person was killed and one was paralyzed by a rock from space. Now, we didn't know about this until very recently because it was written in the state archives in Turkey in a language, this Ottoman Turkish, that very few people know. Someone recently translated. There's documents there in their official archives talking about a very bright blue light, a smoke trail, and rocks falling from the sky for 10 minutes. Now, that's pretty darn extraordinary, but that's what the documents say. And the crop damage that the people described seems to indicate something similar to Tunguska, an airburst with the resulting shock wave, which I'll show you a little bit about later. So now there's 2 quote unquote documented cases of people getting hit. Two people, poor victims back in 1888. All right, I'm almost finished here. 2 quick videos I want to show you. This video was made by a guy who got a new, what do they call those video cameras? Shoot. Anyway, there's a little portable video camera, and he was just a GoPro. and he was testing it, and he was walking along the beach in Australia. So I'm going to start this video. You'll see him walk along the beach. He sits on the bench, and he looks toward the ocean, which is on our right now. And of course, it's a cloudy day. You can't see any meteors 30 miles up on a cloudy day, right? So he's walking along. He doesn't expect anything. He sits down. You can see the ocean, a cloudy day, and he's just testing his new camera, having a rest on the bench. See if you can see the meteorite. It's just barely detectable. Okay. When I play this and you can hear the sound, it's a big boom. It's like a bomb. Okay. We weren't able to play the sound for you. But as you can see, it was not 30 miles up. It wasn't even 1 mile up. If he had a big hat on, probably would have knocked his hat off. Okay. He was in the right place at the right time to see a nice meteor. Okay. The last video, I believe it's the last one I have to show you, is you might have heard about this. It made all the papers, as they say. Wow, this is 7 years ago now. Time flies. Russia. Okay, a guy is driving along. He's got a video camera on the dashboard of his car. Don't ask me why. I don't know. He stops at the red light like a good Russian driver. He's on his way to work in the morning. As you can see, it's early morning over there. And watch in the upper left-hand corner, you might be able to detect it. This is a rock 50 feet across. Size of one, almost as big that caused a meteor crater. Gets brighter than the sun. It explodes 18 miles up. It burns up and it's gone. And it's setting off car alarms. He was in the right place at the right time to get the nice video. Okay? Now, as you could see, it came in on this low angle, right? And it burnt and it exploded 18 miles up. That's good. However, by the time the shock wave, it took around a minute or less for the shock wave to hit the ground. When the shock wave hit the ground, it broke windows all over town, injured over 1,000 people from flying glass, collapsed a few buildings. It was a mess. So that's bad. Injuring 1,000 people is bad, but if it would have come straight down, there would be no town left. The town wouldn't be damaged. It would be gone. It would be like an H-bomb. And so I believe the correct phrase is they dodged a bullet. Now, the ironic part is we did not see this meteor coming at all. As a matter of fact, on that very same day, we had telescopes facing in the opposite direction because we knew there was going to be a close approach to Earth of a completely unrelated object. This thing came from the direction of the sun, and nobody points their telescopes over there normally. This was a surprise. So, surprise, surprise, right? I'm glad it came in on an angle. By the way, you might notice, you might remember that shortly after that, there was the Olympics in Russia, in Sochi in Russia. And on certain days, if you won a gold medal, on the back of your gold medal was a piece of the Chelyabinsk meteorite. Chelyabinsk was the town where the windows were broken. And this is not my gold medal. I did not receive a gold medal that year or any year. Anyway, so that's how you can, that's one way you can get a piece of the meteorite. Go to the Olympics, get a gold medal, you get a piece of the meteorite. Okay, now, my meteors. Trevor, do I got about 5 minutes left to show him meteorites?
You have plenty of time, and we have a couple of questions we need to get to you too. So go ahead and show your meteorites.
Okay.
The questions after that.
That sounds fine to me. Fine. Okay. Meteorite number 1. This is an iron meteorite that I own. Now look, see, 3.5 inches across. Looks a lot bigger. I tried to take nice pictures. You can see the black fusion crust. You can see the brown rust as we described earlier. And 580, it's the size of maybe a little smaller than a baseball, 580 grams, piece of solid iron, okay? Here's another iron meteorite that I have that it's on loan from that museum, the Manning Museum up in Fort Worth. Very similar look to it. The yellow dot is just a paint that they put a paint dot on it for identification purposes. And then this edge of the meteorite was lopped off, and you can see that in the lower photograph, and you can see it's pure iron. Well, actually, they're iron and nickel, typically. It's iron and nickel that are in the center of asteroids and planets. And this is one that shows you a fusion crust on the outside, but pure iron on the inside. Again, almost the exact same size, 3 inches across and 579 grams. I put it in grams instead of ounces because grams makes me sound very scientific, okay? Now, we showed you the iron crystals. When you cut open the iron meteorite, these are 3 that I have, and they are 24, 43, and 82 grams. These are thin slices that are something around less than just under 1/4 of an inch thick. All right, so this one's 3 inches across. And the iron crystals are very obviously. Now, when you slice open the iron, as you might have noticed, whoops, you don't see the crystals over here. You have to etch that iron with acid to get the impurities out of the way, and then you can see these iron crystals. By the way, the lines are called Widmer-Stratton lines. Just a little piece of trivia for you there. Anyway, so that's what they look like. Again, just a few inches across. These are readily available, not that rare. Here's a stony meteorite I have. Now, I did not put the size of it. Okay, it's about the size of a golf ball. Okay, I neglected to put, you know what, or is it underneath? I can't see it on my screen. Is it underneath where it says oriented stony meteorite? I think it probably is.
Yeah, it says 81 grams.
Okay, thank you. It's blocked on my screen. Okay, so it's stony. The outside and the inside are kind of pretty much the same. We do have a nice fusion crust, right? But there's little or no iron in it, and certainly not attracted to a magnet. By the way, the iron meteorites, a magnet will slam right up against them, and you can find them on the ground with a metal detector. They're pure iron. Now, this one is interested. It says oriented, and that's referring to this rounded part of it here, which is this is the back side, this is the front side, and this front side oriented means as it was falling through the atmosphere and heating, the surface was melted, and it kept falling with the same in the same orientation with this point facing forward, and so it got melted and shaped as it was falling through the atmosphere at that high temperature. As a matter of fact, the shape is pretty much like the nose of the space shuttle. Okay, it really looks just like it. And so sometimes they get shaped as they're melted as they go through the atmosphere, and they refer to that as an oriented meteorite. Here is another a chondrite. Now, so this is similar to the one we just saw, absolutely beautiful fusion crust, less than 3 inches across, 125 grams. And look at the tiny little iron crystals. There's iron, a very small amount of iron, and it's just chondrite, and that means it's been melted. Okay, it's in its lifetime, it's been melted. All right. Now you remember the guy holding the big palisite with the sun shining through it? These are my palisites that are significantly smaller than his. They're less than an inch across, so they're much smaller than they look in the picture. 1 to 2 grams, but these are the same. These two are the same, and these two are the same. I just photographed the other side in different light just to give you a feel of what they look like. And here you can certainly see the iron and the olivine crystals in them. And yeah, I only get small ones because they cost more money. Case closed. That's the whole story there. But that's the palisites, and I could have made really nice earrings out of these, but that won't happen. Okay, so what's next? Oh, here's a chondrite. And it's also, look at it, it looks big, right? It looks like it's a foot across. It's only 2 inches across. And so here's some more of these chondrules, these little starters of the solar system in this one here. So it's a real nice specimen. Oh, by the way, I purchased this one back in January or February at a stone and gemstone show in near east of Houston, near NASA there. East of Houston, I forget. There's a show theater place. Anyway, like where they have conferences and things. And so it comes there every year around January, February, and you can buy yourself some meteorites there without going to the moon or Antarctica or anything. Now here is that one that I showed you earlier, the chondrite with the chondrules. And it's really the same thing we already saw. Again, these are the look at this is only 3/4 of an inch across. And these are the beginnings of the solar system here, 4.6 billion years old. When I show people these meteorites in person, I let them touch them. God knows what possesses me to do that, but I let them hold them, and I tell them that no matter what you do in the rest of your life, no matter where you go, this is the oldest thing you'll ever touch. 4.5, 4.6 billion years old. But sorry, can't do that tonight. Here's the Chelyabinsk meteorite. Now, it looks big, doesn't it? This is 1/3 of an inch across, 1 gram, the smallest amount that my scale could register. And I don't dare take it out of the box because I'll lose it for sure. But this I came from a reliable source that said this was a piece from the Chelyabinsk meteorite in Russia. Oh, by the way, if you're going to go out and buy meteorites, you got to know what you're doing, and you got to have a trustworthy source. Okay. I have a couple very trustworthy sources, and I would trust them to the moon. But be careful. That's all I can tell you. Because let's face it, you look at this rock. Can you tell it's a meteorite? I can't. You got to know what you're looking at and how to see them. Now, I showed you that meteorite that fell in Africa, that was discovered in Africa in 1997. This is so small, I can't even register it on my scale. This is the box. This is the meteorite here. It's a piece of Mars. I came from the museum in Fort Worth, and if you look really hard, you can see it. But she was nice enough to me to loan it to me. By the way, these cracks in the case did not happen from the impact. This just happened during the U.S. mail. So I have right now a little piece of Mars, but you know, again, I don't dare take it out of the box. If I drop it, I'll never see it again. That's for sure. And then the lady at the museum will send big people over here and kill me, I suppose. Anyway. Oh, and so that's time for my questions. So I'm certainly ready to take questions. Oh, and by the way, normally I can't see you, but for all of you that were there, and especially those who have stayed, thank you very much for your attention, and thank you for your questions also. Oh, by the way, that picture is not a meteor, as you can see. It's a re-entering vehicle, spacecraft from several years ago, but the picture was so doggone good I couldn't help putting it in. All right, that's it for me.
All right, Bill, we have a question concerning, can you explain where and how you buy and sell meteorites?
Okay. I told you about the rock and mineral show in January, February in east of Texas, east of Houston. And I'm sorry, I don't remember the name of the place, but you just look up rock and mineral show in January, February, and you'll find it on the internet. The other thing is there's a huge one in Tucson in the spring, and I don't know, like for instance, this year, it's probably not, almost certainly didn't happen, right? That one is much bigger and has a lot more meteorites, right? And then there is the evil abode of the devil called the internet. Now, if you get an iron meteorite with Windma-Stratton lines showing on it, you got a meteorite, okay? Look around, you know, for prices, and it's always dollars per gram. It's always how many grams is the thing. But if you see the Windma-Stratton lines, there's no doubt. If you see a fusion crust and it looks like pure iron on the inside, I'll bet you a shiny dime that's a meteorite, right? If you can see the chondrules, it's a good bet, but you know, you're taking a little bit more of a chance there. But so the internet, you know, I would never buy one on the internet. I'll tell you that. But see, I'm in a situation. I know a couple of guys who are collectors, okay, and these guys don't take their medication, so they poor guys. They got so many of them, it's ridiculous. And so I can get stuff from them. Or my friend, he would go to the show every year in Tucson and bring me back stuff, right? But that kind of situation is hard to find. That's about all I can tell you. I bought several meteorites from a place called Lone Star Meteorites. They went to that show east of Houston in January, February. I would trust them guys. You know, when I see their stuff, I can tell it's good stuff. And the guy is good. I've gotten several good ones from him. I live in Katy. There's a place in Katy called the Katy Rock Shop. Tiny little, almost like a storefront. K&E Rock Shop. They are reliable people. I can tell you that. Right down the street from me. But I've purchased a few from them. That's about all I could tell you about where to get them.
Okay. Next question was Lake Saint Jean in Quebec made from a large meteorite?
Yeah, if that's the lake that I think it is. I think I showed a picture of that when I was showing you the large craters on Earth. Whoops. Come on, where was that? No, this is Quebec. Oh no, oh, Manicouga. No, that's different. Okay, I'm unfamiliar with Lake Saint, but quite frankly, there's lots of pictures of other craters on Earth. I only put the 6 big ones. I'm not familiar with that one, so I really can't answer that question. However, if it's round and it's really big, the operative phrase is good bet.
And finally, this will be the last question. Where in Houston has the best collection of meteorites, I guess, to be able to see?
Ooh. I'll tell you, you want to know something? This is going to sound weird. The short answer is mine. Oh, wait a minute. No, I'm trying to think of, I don't know that many people who have this contracted the illness that I have. However, the Science Museum downtown has several nice ones. I'm trying to think if there's any place else in town. The Science Museum definitely has some good ones downtown. And, you know, there's probably at universities, they might have some stuff, you know, in their geology, astronomy departments, perhaps, but I can't say that I know that. Then there's this museum, the Mining Museum. It's not in Houston, it's in Fort Worth. There's a day trip for you, but wow, look online. You'll see their gallery, their pictures. It's a real nice museum, and they got a really nice collection. And you know, they're easy to see. They're displayed beautifully, and that would be the closest really big collection that I know of.
All right, thank you.
You're welcome. Thank you again for your attention.
All right,
Bill,
back to you,
thank
Doug.
you very much. All right, got it. Okay, Bill, thank you very much for that presentation, and thank you for being our main speaker tonight.
My pleasure.
Next on our agenda. Thank you. I was just going to say a word about our JSCAS Loaner Media Library. When we start having meetings together again in the future, Ron has told me that he's got several new DVDs, so I'll give something to look forward to next time we reconvene. Next on our agenda is Chris Wells with automated imaging results. I'll turn it over to Chris.
Okay, good evening. My name is Chris Wells. This is really part 3 of part 3 presentation. We gave a presentation both in May and June where Trevor Quinn and myself co-presented on the use of mini computers to actually automate some imaging using our gear at home. This part 3 is going to take that a stage further and I'm going to first of all do a recap of some of the equipment that we're using. I'm going to then talk about a new feature that I used in K-STARS called the object sequences and how to use those. And then I'm going to show you the actual astro imaging results I've managed to get in June from my own backyard, which is light pollution central. Okay, so first slide. Okay, so this is my recap slide. If you recall some of the earlier presentations in May and June, we talked about using these mini computers. One here on a mini, which is a Raspberry Pi connected to an Ioptron mount, and we use that one. Another one is a small NUC mini computer, also running the same software. And the idea being is how to use those mini computers to control both this small rig here or this big rig here. And using the K-STARS ECOS software, some of the things that we managed to get it to do while sitting in the comfort of inside your own home, we managed to get these both the big rig and the small rig imaging for us while we're sort of indoors and the equipment's doing the hard work outside. And little check marks here indicate some of the features that we proved and got working. One of them was the go-to capability, one was auto-focusing, another one was auto-guiding, plate solving for positioning of objects, and also some image capturing software. And these were some of the images that I presented, I think, at the last May meeting. I couldn't help but show this picture here. I actually had a neighborhood visitor from our local neighborhood lake, which is about 400 or so yards away. He was obviously a little bit out of territory, but I caught him looking up. So that's our motto for the night: keep looking up. And with the big rig here, obviously we're capturing kind of images like that. So a little recap of the technology there, and a little friend who came around and saw me. I actually saved him, by the way. I took him back to the lake, and he went back in. So one turtle saved there. Okay, so the new feature that I used in the K-STAR software was something called Object and Sequence. So there's an Object and Sequence Selection tab. And the idea being here is you can set up an imaging sequence for an entire night, where it goes from one object, let's say Messier 5 to Messier 17 to Messier 22. And you actually set them off in a schedule to take a number of images each. You also say, well, what do you want the software to do? You want it to go to the object, so you want to track and go to the object. You want it to align, in other words, you want to plate solve, because you don't want to image a blank space of sky. You actually, when it goes to M17, for instance, which is the Swan Nebula, you want it to align and center M17, then you want it to guide, and then you want it to take the pictures. So you're actually setting it all up in a sequence where the software is doing the work for you. And the idea being is once you set up a sequence like this, you can leave the big rig or the small rig outside completely unattended. And while you're sleeping, it's doing the work for you. That's the idea. The idea is to sleep as much as you can and let the equipment do the work for you. And then hopefully when you wake up in the morning, there aren't any wire issues, there aren't any equipment issues. You come back and you have a hard drive full of images. That's the beauty of this object and sequence selection. And I put a little check mark next to it, proving that I did actually get it all working. I wanted to highlight here the twilight setting. The first time I used this software, I woke up in the morning and it looked like one of the imaging runs had aborted on me. It didn't quite finish. I think it was M17 or M22. I can't remember which one it was, but it actually indicated that it stopped, and I didn't know why. But when I looked through the logs, it's this twilight feature kicked in. So if you don't time it right, you clearly don't want your camera imaging when the sun's coming up. So this actually turns off the entire system when a certain period, predefined period before twilight. So I didn't think that, I thought something had failed in the first time I used this, but actually it was safing itself, so that twilight feature was very, very useful. Another feature down here is after an imaging run is finished, or if it reaches twilight, the software will actually abort for you. And when it finishes or it aborts, it will warm up the CCD camera, because there's no point leaving the thermoelectric cooling device on, and it'll also park the mount as well for you. So all of this kind of was proven out by using this feature. So anyway, the idea behind this is set up your sequence, let it do the work for you while you're sleeping, and then fingers crossed you get up in the morning and you have a whole hard drive full of images. So that was the idea, and it did actually work. So first thing is you've got to have an opportunity to play with this technology. Now, if you try and doing it for one night, it doesn't always work. And then you've got to wait another month and you forgot where you got to. Well, in June, we actually had 7 great imaging nights in a row, which is like quite kind of rare. There wasn't any, there was very little or if no humidity. So really between June the 13th all the way to June the 19th, I simply left the big rig technology outside and let it do its thing every night. And you know, I was talking about a hard drive filling up. These are all the images that it automatically created for me. Some of them were attended, as the first night I think I stayed up to 4 a.m. myself. But the second night I probably didn't. I left it going and went to bed at a reasonable hour. So that's how I got a whole hard drive full using that sequence generation. So that's what it looks like. And then what I'm going to do now is actually show you some of the pictures that I got from this wonderful humid-free 7 nights in a row in here in League City, Light Pollution Central. The first image I'm going to give you, though, is going to be a little bit of fun. I'm going to show an image of something I found out there. Well, something is already out there, but I took an image of. So this little nebula down here is at the center of a much bigger nebula, and I think it looks exactly like the Starfleet insignia. You see that? That's the insignia off of Captain Kurt's shirt. And just look at the curves on that emission nebula like this. Doesn't that look like the Starfleet insignia? It does to me. So the audience question is, this is only a zoomed in area of a much larger emission nebula. The audience question is, what object in the sky is this a part of? A much bigger part of an object. So it's a much larger wide field nebula, and this is in the center of that nebula. So that's the question. I'll come back to the answer of that by showing you the image right at the end. So just wanted to throw that out there to the audience to see if anybody knows or has seen that object before. And I saw Justin just ask the question, what's the designation? You tell me, that's the question. What is the designation? I'll give you the designation at the end. Okay, so my first image is the M83. It's the Southern Pinwheel Galaxy in Hydra. Once again, this is my C11 setup, my big rig. It's got a hyperstar lens in it, so it images at f2. So it's a very, very fast optic, and I'm using an ATIC 460EX color camera, which is a really very high sensitive camera. It's got a quantum efficiency, I think, of around about 80+%. So it's really capturing a lot of photons in a very short period of time. This is the, as I say, the Southern Pinwheel Galaxy, and that I took 44 images, each being about 2 minutes a piece. So that was one of the earlier images I got. Next one. This is a picture of M33. This is a 2-for-1 deal. What I sometimes like to capture is more than one object in the same image. So I managed to capture M53 and NGC 5303 in Coma Berenices, and that was 22-minute exposures. My third image I got during these nights was it was Ptolemy's cluster, M7. What I love about this picture is it's right in the middle of the Milky Way. Just like everywhere you look, there's just stars everywhere. And once again, this is another 2-for-1 really, because not only are you getting M7, Messier 7 in the center there, you're getting a lot of dark nebula in different places. And the more you look at the dark nebula patches, the more and more you start to see shapes in it. So this one here makes me think of a person. This looks like a person shape to me. It looks like the arms are stretched out as though the person's actually running. And perhaps this is a woman that's running, because you see the head there, maybe a ponytail coming back there. So what I see when I look at this image is not only a lovely star cluster in the middle of the Milky Way, but I also start to see this Barnard 287 object that looks to me like a lady who's exercising and running. It's another one that's close by. This is another really a naked eye object, M6, sometimes called the butterfly cluster in Scorpius. These are very naked eye objects. When you look at Scorpius on the border of Sagittarius, you actually see M6 and M7 pretty close by, and you can see the naked eye. Once again, another picture just managed from here from Light Pollution Central, meaning my backyard here in League City, Texas. Here's another 2-for-1 that I managed to capture. This is the Firework Galaxy, NGC 6946, and the Open Cluster. Once again, another two objects for the price of one, captured at the same time there. This one I had to go a lot deeper. I ended up taking 108 pictures, about 2 minutes a piece, in order to get out some of the or draw out some of the structure there in the Fireworks Galaxy. This one was more of a challenge object. It's not a very good picture, but I've included it tonight. The reason being is it's so low down. I don't think I've ever tried to image way down in Centaurus before. This is NGC 2158. It's sometimes called the Hamburger Galaxy. The challenge on this object was it was so low down, it was actually grazing the tree. And so I call this my tree filtered image. But I did manage to get a quick image, really, just 20 minutes of exposure in total. Okay, and for my last image, that's the answer to the question. Has anybody found know the answer of the designation of the object where, well, I'm calling the Starfleet insignia is? Has anybody offered a question there? Do you see any in there, Trevor? I see one question. Oh, now it's the U.S. Space Force. It is pretty similar to the U.S. Space Force insignia, that's for sure.
Yeah, I didn't see anything, Chris.
Okay, drum roll, drum roll. So the answer to the audience question is, you actually see it right there in the center of the Cat's Paw Nebula in Sagittarius. So that is designation NGC 6334. To me, it was just so obvious. It was right in the center, and it just jumped out at me. And it happened to be, well, when I processed the image, it happened to be the right orientation as well. But to me, the curves on that emission nebula piece in the center there look exactly like the Starfleet insignia to me. Or maybe I've just been looking at my images too long that I start to see things. So that's about the presentation I've got. I got through about 60% of the images in those 7 days. I hope you like them.
Hey, Chris, were all the images taken in June?
Yes, all of them were taken in June in that one week that we had to, in that 1 week of June. And there were probably I probably got about another 4 or 5 images that I'm yet to process from that 1 week, which I think speaks volumes to some of the automation that we put in place, because that sequences and having things go automatically through the night while I'm sleeping really does pay dividends.
Okay, we'll head back to Doug.
Okay, next is I have a member's minute on how do you say that. So if you have been around the astronomy community for any period of time, you will notice that you'll hear people saying the same words in many different ways. And we've had a lot of fun at star parties trying to speculate about how different celestial objects are actually supposed to be pronounced. Recently, actually in the June issue of Sky and Telescope, I ran across a pretty good pronunciation guide for the constellations. And it's shown here on this slide, is.gd/constellations. You can go there and you can see the 88 constellations, and it will tell you if there's more than one correct pronunciation for the constellations. And it also has a link you can click on. You can hear someone actually say the names of different constellations. So next time you're trying to find out how the correct way is to pronounce constellations, this is one guide that you can use. Next up is David Haviland with Star Party News.
And that was a quick members minute there, Doug.
Supposed to be a minute, right?
All right. Here we are. June 26th, we had an event at Winery. I'll talk about that one. Saturday, June 27th, we were supposed to have an event, Asteroid Day and Planetary Defense at the LPI. They turned this into a virtual event where people dialed in and hopped in through Zoom. So I don't think there was anything, people didn't come on site for this one. Saturday, July 18th at the LPI, this is tentative. HAC is tentative. And again, back at the LPI is tentative. This is all tentative all the way out. We are probably going to work and have the all clubs meeting virtual. Don Selly, I think I mentioned this last month, Don Selly at HAS is willing to host this with their Zoom because they can do out to 400 people. This will probably not transpire. We're already talking to the museum on that. That's just the way it's going to be, and we have no idea about this event. We are in a holding pattern. We're going to be in a holding pattern for quite some time. With deep appreciation to Bob and Leslie Eaton, they came out and manned the event. You can actually see a singular patron over here. The winery, because of the events Friday with Harris County going to red zone, classification red, and issues with Galveston County, I think people on both sides just decided to stay home. It was Bob and Leslie, and they had a grand total of 10 people in attendance, and they were pretty much on their way back home by about 8 o'clock, as I understand it. And I do thank Leslie for supplying the picture and making the effort to head out there. As I said, everything is pending. Those hoping that the George will be open anytime soon, it is basically to be considered closed until further notice. George has to take its marching orders from HMNS Sugarland, and Sugarland hasn't opened yet. And until things are working at HMS downtown, things as far as the Georgia concern are on indefinite hold, and as is outreach. And if you've been watching the news, we know what's going on as far as the schools. We don't know what's going on there. So we're in one big holding pattern, folks, unfortunately. Now, on the bright side, Paul Maley, and I just dropped the name of the comet we were just talking about a little bit earlier, got these from outside his house in Phoenix. This one, I believe, was taken on the 8th. This one is taken on the 9th next to a big saguaro cactus. You can see the huge tail coming off. This is an airplane. This, I believe, is an 8-second exposure through his camera that he uses for the auroras and northern lights, and roughly ISO 800. So he's got some really nice pictures from Paul. I know there's some people in Europe that are getting great pictures, but I like showing pictures that come from the club. And that would be it, Doug. Back to you.
All right, thank you very much. Trevor, did we get a question in the middle of that? Maybe not. Okay. All right.
Doug, it was your question if you want to ask it.
No, I saw something else. My mistake. Okay, David, thank you very much for Star Party News. And that is it for our meeting. So please plan to join us next month on August 14th, where Paul Maley will be bringing us around the world for an eclipse plus Starlink and the future of the night skies. Thank you very much for attending. See you next month.